สวัสดีค่ะสวัสดีค่ะ Dear members and distinguished guests, good evening. My name is Sujintana, or you can call me Ning, and I am your MC for tonight. On behalf of the SPE Thailand Board of Directors, I would like to welcome you to the SPE Thailand season opening. Thank you for being here tonight, and we are happy to see many oil and service companies, government representatives, and academia from the upstream oil and gas industry supporting this season opening and awards dinner. Also, a special welcome to our students. Please raise your hand. I think we have almost 40 students joining to show us where you are. And thank you for joining us. At tonight's event, we hope to show you how our industry continues to create and innovate to meet our future energy needs. The industry here in Thailand is unique and perfectly fit the SPE mission and vision. We network and we share. Tonight, we will have two highlights. We will start with our SPE Thailand Young Professional Presentation Contest winner, followed by a keynote talk from the CEO of Valeura Energy. I would like to point out that the SPE Thailand section has been active here for over 43 years and maintain a solid membership base. Good relationships with oil and service companies have always provided sound annual sponsorship support. And this support has enabled the section to focus on value for members, student members, and guests. SPE Asia Pacific even recognizes that the Thailand section is consistently the most active section in the region. So now I would like to read out the sponsor here in appreciation of their support. Audacia, Baker Hughes, Bangchak, Bluefin Petroleum, Bow Drilling, Chevron, CUEL, ERM, Xlog, Xpro, Fugro, Gaia, INSEE EcoCycle, International SOS, JST Group, Medco Energy, MMSVS, Moeco, MPC, OGAS, Oil States, OPS OES, PAPS, Pan Orient, Palang Sopon, Production Solution, PTTEP, Rovula, Rystad Energy, Silica Hill, Scientific Drilling, SLB, Tendega, Thailine, TTS, TNS, TOS, UAL, Valeura Energy, Vinaco, Weatherford, and Department of Mineral Fuels. So please, can we have an applause to all our sponsors shown here on the screen? Thank you. Before we continue with our program, please take note of this safety announcement. There are no emergency drills planned for tonight. So in case the alarm goes off, please remain calm and look for the nearest emergency exit, which are all clearly marked. From there, the hotel staff assigned to this ballroom will guide us down the stairs and to the assembly point outside. It is important for everybody's safety that you remain calm and don't rush. Also, if you observe any suspicious activity, please do not hesitate to report this to the hotel staff for everyone's safety concern. So here is our agenda. I will highlight some of our activities. We will then have our presentations, followed by some closing remarks and a lucky draw. You may notice the lucky draw docket on your table. Please fill them with your name, and the hotel staff will collect them towards the end of the program. And I hope to keep things on schedule with the first talk in about 10 minutes. Our keynote speaker should start around 7:30 on the energy transition, and we should finish around 8:30. So here are some of the SPE Thailand highlights from the last season. Every year, we run an SPE Thailand scholarship program for SPE student members in Thailand. We basically run a mini competition requesting students to provide their motivation on why they think they deserve an SPE Thailand scholarship. Then we interviewed the student in a committee and assigned the scholarships to the highest ranking students. Last season, we provide 14 students with a total of 190,000 Thai baht on scholarships. Our program continues, and please help us spread the word. The young professionals make SPE Thailand promotional visits to schools and universities. Here are some pictures of the recent visit to the Prince of Songkhla University, and more visits are planned for the new season. Every year, the young professional organize a young professional presentation contest to young professional and students. Tonight, the winner of last season's contest will give the winning presentation. And the young professional will travel virtually through ASEAN in 2023. ASEAN Young Professionals Energy Connection Series. These are monthly webinars, and each episode will feature speakers from a host country to share their insights in our industry. Please note our section supports 4 student chapters: Chulalongkorn University, Suranari University, Prince of Songkhla University, and Chiang Mai University. Chulalongkorn University just won an Excellence Award and had an SPE orientation to inform engineering and geology students on SPE activities and as a hub of knowledge sharing. Suranari had a 3-day petroleum technology excursion where they visited PTTEP on geological structures. And at Thai Oil, they got information on upstream, downstream, and logistics. And at TPTI, learn about safety such as helicopter underwater escape training. Prince of Songkhla University did an introduction to oil and gas with over 40 students, and Chiang Mai University is planning a job observation field trip later this year. We have quite a number of students in the room today, and they represent our future in the energy industry. I encouraged you to take some time to engage with them, as they are the next generation responsible for sustaining the energy industry and its vitality. We are almost there, with just a few more slides to go. I would like to draw to your attention that we'll be launching our SPE Thailand E&P Award competition in October, which is next month. And we invite you to share your projects and submit your applications before February 2024. Who knows, you can be the lucky winner. And in our season opening next year, we will announce the award winner during a special dinner like this one. And also, please keep in mind that all these activities are made possible due to a lot of hard work behind the scenes by our volunteering board members. So here are SPE Thailand Board of Directors and Young Professionals Committee for this season, 2023-2024. We have a total of 16 volunteers, so please raise your hand when I call your name. Our chairman, Khun Ronald. Our secretary, Khun Anupong. Our program chair, Khun Kasian. Our ENP Award Chair and Vice Program Chair Khun Panit. Our Vice Program Chair Khun Chia. Our Membership Chair Dr. Trin. Our Vice Chairman and Scholarship Chair Dr. Yingyot. And our University Liaison Dr. Jirawat. Our Treasurer Khun Nikon. Our Marketing Chair Khun Tri Thasset. Our Vice Marketing Chair Khun Ratmani. Our Young Professional Chair Khun Warapat. And this is me, Suchintana. Supporting us Industry Liaison Chair, ขอบคุณค่ะ and Vice Industry Chair Liaison คุณวรัยวัฒน์ our Internet Chair คุณเพชร and คุณนิพัฒน์สิน and of course we could not do without the support of คุณหน่อย and her supporters handling our registration desk every month, and also คุณ Annie who step up when we are short of announcers. Thank you. We also have 11 young professional committee members who support us whenever they can. A warm applause for those committee members, please. So now we will kick off our presentation with a young professional presentation contest winner. Can we please have Khun Chia on stage to introduce our speaker?
Good evening, everyone. So hope you guys are socializing. So it's always good and my pleasure to see so many old faces and some new attendees. Welcome. So today we are delighted to have Khun Pornphun joining us to share with us her knowledge on erosion monitoring sensor for well test application. Khun Pornphun started his career with SLB in 2015 in Aberdeen, covering the North Sea and Europe operations. In 2021, she moved to Ankara, Turkey, cover the ultra-deep projects in Black Sea. In 2022, she moved back to Thailand as a reservoir engineer to support the reservoir simulations and software. Khun Pornphun graduated with a master's in chemical engineering from University College London. So without further ado, let's welcome Khun Pornphun to the stage.
Thank you, Khun Chia, for the introduction. สวัสดีค่ะ Good evening all. So this project was completed back in 2019 when I was still working in the field as in surface well test in Aberdeen in the UK. So it was based on the challenges our well test team has faced on erosion monitoring. So today we'll go through a brief introduction and addressing the problem and challenge in what's the problem with the way we do things conventionally before moving on to the project objective in which what exactly do we want to improve on before moving on to the solution proposed and result and conclusion before opening up for a round of Q&A. A bit of introduction here. So why are we doing well tests? So well test is defined as a period of time in which the well is being flowed at a control rate, at which we start flowing out the well all the way from the flow head here, all the way to the choke manifold, through the test separator, and all the way to the flare boom at the bottom there, in which the tubing head pressure is being measured, ideally as close to the flow head as possible. even better if we have the downhole gauge measuring the downhole pressure. And at the same time, the corresponding hydrocarbon flow rate is being measured at the test separator there. Using after flowing for a certain period of time, the well would then be shut in to monitor for the pressure buildup. Using this pressure and flow rate data, the well productivity and reservoir performance can then be determined. And as you can see here, many pieces of equipment are interconnected by many lines here denoted the pipework. And photos on the right show just one tiny corner of the well test package. So that means like lots and lots of pipework involved, right? So as we are handling the flow at surface here, so one of the major risks here being the erosion due to solid production or the high velocity flow, which could result in equipment damage. As you can see in the photos on the right here, maybe the damage to the choke beams, adjustable choke, or like control valves, and so on, right? And it could also potentially result in the pinhole in the pipework and equipment itself, which would then lead to the uncontrolled release of hydrocarbon at surface, which is having the uncontrolled release of hydrocarbon in a close proximity to the open flame, which is our flare, is definitely not ideal, right? So things could have gone very wrong with that, and also could potentially involve the personal injury, in which but all in all, so after the uncontrolled release of hydrocarbons at surface, first thing we need to do is definitely shut down the operation, which then lead to the lost time and red money, which is something that we don't want to happen, right? So this is an example of the case that we didn't want to happen, in which 20-inch of high pressure gas pipeline has been ruptured and resulting in a fire afterwards. This could have easily been detected by the pipeline operator, but unfortunately, the pipeline itself went uninspected for over 24 years. So how can we make sure that similar incident doesn't happen again in the future? So in SLB here, we have a standard practice of carrying out the thickness check for pipework wall at the elbows, which is the spot most prone for erosion to happen at fixed interval depending on the flow conditions. So we do this a bit more often for the flow that containing solids or with the high rate gas flow, which are more prone for erosion, right? So we have our friend here in the shiny orange cobalt going around the well test package with the handheld ultrasonic device, going and take the measurements on each and every one of the single elbows on the well test package, and then write those numbers down onto a piece of paper in a reading sheets before handing the reading sheets to our data acquisition engineer in the lab cabin, which would then manually type this number one by one again into the spreadsheet here, which would then tell us if it's still safe to continue to flow or not. So if the number turns green here, then all is good, we can continue to flow. If the number turns yellow, then okay, we know for sure that some erosion has occurred, but it's still within the allowable limit, so we can still keep on flowing. Once the number turns red, then that we know that the maximum allowable erosion has been reached. We need to shut in the well as soon as possible. And as you can see here, the response time between when the measurement has been taken and when we can identify if it's still safe to continue flowing or not, that response time is too long, right? So, and to make our friend here life like even harder. So the photos on the left show some of the inaccessible spots around the well test area. The first one being the scaffolding over the pipework itself, which allow easy access around the area, but at the same time, it also cover the large chunk of the pipework itself. Second one being the insulation layers wrapping around the pipework in case of high surface temperature to prevent personnel from accidentally touching it and injuring themselves. The third one showing the tie down sling, which is there as again as a safety feature also to prevent the pipework itself from flying all over the place in case of pipework rupture. So from the previous slide, did you identify any area of improvement there? How can we do things a bit more safely and efficiently? First of all, being the resource. So it actually takes quite a lot of time to manually take in like every measurement on each and every single elbows in the well test package itself. And also, for example, of like the frac flow back operation in which the manual measurement is required every 2 hours. However, at the same time, it also requires around 2 hours as well to manually complete one round of thickness measurement. So this is impossible to do unless we add one extra crew member on each shift just to work on this wall thickness measurement, right? Second one being the inaccessible spots around the area. As we saw on the previous slide, maybe under the scaffolding or like under the insulation layers or under the tie down slings. So the fact that we cannot reach those spots for taking the measurements doesn't mean that erosion is not there. Third one being the data quality. So you probably cannot see it that clearly from the spreadsheet from the previous slide, but there's some data inconsistency there. For example, during the pre-flow, we might be able to measure the pipework wall thickness of 19 millimeters, but during the flow, we measure again at the same spot, and then we might get 19.2 millimeters. But it doesn't make sense. How can like the pipework wall thickness just go up like that, right? This could be due to human errors since all this measurement has been done manually. Last and most important of all being the HSE rigs. So having personnel going around the well test package over the pipework, under the scaffolding, especially during the BC well test period. This increased the risk of tripping, slipping, and falling, which then lead to personal injury, which we don't want to happen. And also the fact that erosion could happen in just a split second. So ideally, we would want to keep personnel away from the pressurized system and potential line of fire as much as possible. So what do we want to achieve here? So we want to provide an innovative solutions to the problem addressed in the previous slide. It be the reducing the time spent on the manual measurements, minimizing the HSE risks, and also improving on the data quality itself. But ultimately, we would want to put this wall thickness measurement as an integrated part of our well test data acquisition system to allow continuous monitoring of the data itself. So on the right here, we have on the left here, we have our well test package. And on the top, as you can see, we have our well test data acquisition system, acquiring pressure, temperature, and flow rate data using the wireless sensor, which would then wirelessly transmit the data across to the lab cabin on the right, in which we have our engineer monitoring the data at all time. On the other hand, at the bottom here, we have the pipework wall thickness being manually measured in the handheld device and then manually enter into the spreadsheet one by one. So I was thinking, can we do something a bit similar to the well test data, but for the pipework wall thickness measurements, so that all the points are pushed automatically into the data acquisition system and to get rid of all the manual works required. So, which come to the digital sensor for erosion monitoring here. So how does it work? First of all, the sensors would send the ultrasonic wave through the pipework wall, which would then be reflected back and then wirelessly transmitted across to the acquisition computer. And then in the acquisition computer itself, the pipework wall thickness would then be computed and stored in the database, which would then allow us to see the trends over time as well, if the erosion is happening or not. A bit on the project timeline here. So we first started off with some window shopping. Since erosion is not a problem exclusive to oil and gas industry. So other industry also face this challenge as well. So there were some quite a few options available on the market, right? But it needs to meet certain criteria in which to be used in our situation. First one being the sensor itself need to be intrinsically safe to be deployed in the hazardous area. Second one is that it need to be non-intrusive to handle the high flow rate conditions. And last of all, ideally, the system would need to be compatible with existing SLB well test data acquisition system. And after the sensor of choice has been identified, some preparation has been done on sensor commissioning and some document preparation before we kickstart on the first field test, in which it was a frac flow back operations on a high rate gas well, in which, as we mentioned previously, typically for the frac flow back operation, manual measurement for the full system is required every 2 hours. So by utilizing this sensor, we managed to cut down the crew size by 1 person per shift, and the client project was completed successfully. Client was happy. So after the project itself, we continue to work on the integration into the SLB data acquisition system, which we managed to complete before the second field test, in which the second field test was a project in which the client was concerned about the solid production at surface because of the particle size was smaller than the screening. It was proved to be seamless integration between the digital wall thickness reading and existing well test acquisition system. So far, we continue to implement this digital solution on the projects worldwide. So far, 6 projects has been completed, 3 in the UK, 1 in Norway, 2 in Turkey. With the latest project being completed was a long-term cleanup campaign on a drill ship in Turkish Black Sea, which would give us like a beautiful number of 0 lost time injury, which is exactly what we're hoping for. So what exactly has been improved? First of all, being the real-time trend and comparable result. So this allows continuous monitoring of the pipework wall thickness at the otherwise inaccessible spots around the well test area. We can also monitor this data anywhere, may it be at a well site, may it be at the office in town, or at the comfort of your home. Second one being the time spent on the manual, less time spent on the manual measurements. So as I mentioned previously, right? So manual measurement for the full system check is required every 2 hours. For typical well test operation, that need to be done every 4 hours. So by having the comparable trends being continuously monitored, we can reduce this number down to once per shift, which is once every 12 hours. Also, very closely related to the second one, being the third point being the crew size reduction and increasing in crew efficiency. So instead of going around back and forth and taking the pipework wall thickness at a fixed interval, the well test team members can actually concentrate on the operation itself. And as we mentioned previously again, in extreme case, this could lead to the crew size reduction also. And last and the most important of all being the lowering the HSE risks, right? So we can see from the hierarchy of controls here that we are at the elimination stage, in which the risk is being eliminated by changing the work process, in which this minimize the time that personnel spend around the pressurized system and potential line of fire, and also minimizing the time people stepping over the pipework and under the scaffolding, minimizing the risks of tipping, slipping, and falling. So, yep, at SLB, safety is always the key for like the operations. So we strive to push the bar for the safety standard, right? So that we can deliver the operation safely and seamlessly to our esteemed client here. So thank you once again. And before opening up for a round of Q&A, I would like to take this opportunity to promote the upcoming SPE Young Professional Presentation Contest for this year. So abstract is still open. Abstract submission is still open until the 30th of this month. So if you have any interesting project you would like to share, as well as to learn from others, if you're interested or if you know anyone who might be interested, please feel free to spread the words. So thank you once again, and I would like to open up for questions.
So we would like to welcome your questions now. Anyone have questions?
So if there's no question, I would like to pass the microphone back to the SPE team then. Thank you again, Ka. Hope you all have a great evening ahead.
You have questions? Behind you, Khun Om. Behind you. Me one question นะคะ
Hello. So as you mentioned, erosion is something that actually is not only for well testing, it's happening for all over the industry. So have you considered applying this in other aspects in the industry?
You mean applying it in the other applications, right?
Yes.
So this solution actually exists for other solution. I think it's mainly used in the food manufacturing and pharmaceutical mainly. But then we kind of adapt the existing solution into the use for something that hasn't been done before. So that's where this project come from. But I think in other application in oil and gas as well, if you think there's any use of this sensors, feel free to reach out. We can discuss this further offline.
Thank you.
Thank you.
Thank you. Do you have any other questions? Okay, otherwise I would like to please ask our chairman, Khun Rano, on stage to present Khun Pornphun with a token of appreciation.
Move to the center of the stage. Yes.
And ladies and gentlemen, we will now continue with main presentation. Can I ask Khun Kasian to please come on stage to introduce our keynote speaker?
Sawadee krab. Thank you, Khun Ning. It is a pleasure for me to be here every year introducing the speaker, the keynote speaker, right? But before I do that, please allow me to have a quick recap of our last season's monthly technical meeting program. So we have committed to sponsors that we would organize every year, 10 meetings, right? And we have fully committed to that. As you can see here, I'm sure you cannot read, but basically we organize from starting from September and all the way to last month. We stopped in April and December for break, Songkran and Christmas. A few of these meetings are very key and very important. May I highlight the few? Basically, we have Khun Montri, who is also here in the room, last year's season opening, giving us a very good insight of everything he knows. And then Thank you very much. And then we also have one very important by Dr. Prasit, Sinsuk Prasit, who we all know, right? He's going to be in a few days the permanent secretary of the Ministry of Energy. At that time, he was taking us towards the Thailand energy plan for the carbon neutralities. Okay. Around the middle of the year, we also have the talk from the DMF as well. This is the topic on decommissioning, and we all know that Gulf Thailand decommissioning is something big coming up, thanks to Dr. Wisarut Tangsunthorn Khun. Okay, and then all the way we have as well the 2021 awards winner, where we presented here on the last season opening, and he also gives the talks. So again, a few of these are very, very interesting, and I know not all of you can come. We have the recorded of all this meeting on YouTube. If you go to YouTube and search for SPE Thailand, you can have a recording as a knowledge database for all this. So please take some time and go and look. Okay, come back to the program. So our keynote speaker has worked in the international energy industry for more than 30 years. He is currently the CEO of Valeura Energy, a public company listed on the Toronto Stock Exchange, which has built a significant business in Southeast Asia and now operated 4 oil fields here in the Gulf of Thailand, producing over 20,000 barrels per day. In addition, the company holds an operated equity position in a very large Thai gas play in Turkey. He has lived and worked in various countries in Southeast Asia, Africa, Europe, and Australia. Prior to joining Valeura, he was the CEO of 2 private junior companies. Texco Energy, a $700 million company, held production, development, and explorations asset in the Australasia region, East Africa. Under his leadership, Texco grew production to approximately 10,000 barrels of oil equivalent per day from its assets in Indonesia and Australia, and undertook several significant projects, including a greenfield oil development in Indonesia. Prior to his CEO roles, he also worked for Woodside in Australia and Libya, and for Shell in the Netherlands, Australia, and Malaysia. He started his career working on the rigs with Schlumberger in Egypt. Sponsor, members, guests, ladies and gentlemen, please join me for a very warm welcome to on the stage, the keynote speaker for tonight, Dr. Sean Guest, CEO of Valeura Energy.
Thank you very much for that lengthy introduction, very detailed. And thank you very much for inviting me to give this address here tonight. And Khun Mantri, Dr. Kujit, thank you for coming along to hear this tonight. So before I get into my talk, which really talking a bit about the energy transition and why I think this is really going to be a boom time for us, not just in the oil and gas industry, but as petroleum engineers, I want to address a couple of questions that have really come up as we've been here for the past couple of years. Right, so 2 years ago, Valeura Energy was in Turkey, where we had a large gas play, and we weren't in Southeast Asia at all. A year ago, when we were at this dinner listening to Khun Mantri, we had picked up a position here, but we had no production. And now we're sitting here a year later, and we've got over 20,000 barrels a day of production, the #2 producer. And the question we kind of get is, why did you come to Thailand? Why did Valeura come here? So before I go into my talk, I'll just kind of address a few points on that. One of the first things is really the experience of the executive in your team is extremely important in deciding where you go. And so for myself, having lived in the region in different countries around here, we're very comfortable in that. And this isn't just an understanding of the subsurface, what the geology is like, what it's like in infrastructure in that, but it's much more important in the relationships that you have in the region, but also beyond the relationships as well. It's an understanding of how to work within different countries. It's an understanding of the culture and appreciation of what's required to work there and to be successful in those places. And that's really one of the first criteria that we had. And it can sometimes seem easy that you can go somewhere and work, but even in some of the major companies I've worked in, they made decisions to go to new basins or new countries, and in the end, 10 years later, can do a review on $3 billion that is lost. We can be very skilled, but working in the country is very important. Market dynamics. Very simply for me, I come from Canada. We've got a population of, I don't know, I think it's 40 million now. But when I'm in Bangkok here, what I say to people is, I can get on a plane and fly 6 hours, and within that diameter, you're going to have half the world's population. It's extremely significant. And the other thing I like about Asia is the energy here, how dynamic things are, and the growth that's happening in Asia. I believe that Asia is going to dominate the world economy as we move forward. And that's why, to me, big population, growth going on, this is really where you want to be, because that growth is going to be driven by energy. Now, about 25 years ago, when I came to the region and first started to work here, we looked at Thailand, and everyone was watching Thailand in this region and watching how you worked. And that's because of the quality of the staff and how you were delivering here. Unocal, with the drilling that was going on in the Gulf of Thailand, was highly respected and really leading in the industry. So this isn't a remote area. This is, you've got quality, well-trained staff who can deliver your projects for you in that area. Another one, when I was in Woodside, building the Pluto LNG facility, that was all constructed here in Thailand because of the manufacturing capability you have here. Now, the other one I put up there, which I'll say is we always want to be cautious on this when we say it. Generally, the fiscal terms in Thailand are very good relative to the opportunity in the subsurface and what you can deliver from that. There are fair terms here, especially when you look at something like the Taiwan or the Thai 3 terms. The other thing that you have is you generally have what we refer to as fiscal stability or sanctity of contract. So if you come into a country like Thailand and you make an investment, you generally know what your returns will be depending on oil price going up and down. You can't say the same if you go and invest in the North Sea, oil prices go high, people complain, and the government puts a huge tax on you. Sanctity of contract is very important here. But one of the key things was looking at the acquisition opportunities that existed here in Southeast Asia and Thailand, and the fact that you could go after these with lower competition. And what was driving this a couple years ago when we started this move was energy transition. A lot of the majors were under pressure to get rid of their oil assets as they kind of moved over and transitioned to become gas companies. And we believe this would create an opportunity to be able to take a small amount of money and buy quite significant assets because of this transition and the strategy of having to leave. Another part of that we still see going on is materiality thresholds, that in some ways for the majors, maybe the play is becoming too small. And I think as we're here in Southeast Asia, this is most pronounced in Indonesia. When I lived in Jakarta about 10 years ago, working there, you had all of the majors working there. You had Chevron as a major producer in Sumatra. You had Chevron brought whole groups of staff in to develop a deepwater project. Total in the Mahakam area doing the LNG. ConocoPhillips, you've seen this move out as they see the assets not material anymore or making moves back to strategically where their own portfolio will be. And this still exists. We see this move going on, and there's an opportunity for companies of a smaller size to kind of come and fill this void. And the last one I'll just kind of mention is late life assets. So if you've worked in a major company, what you know is those old oil fields and that are really unloved. People generally don't want to work in them. They want to work on that new exciting project. And this tends to create a desire that we can get rid of those assets. So we see a lot of that. It's old oil assets, still lots of potential, and people moving away and selling those. And what we know as engineers generally is that these late life assets are going to go on for a lot longer than people plan for them to go on for. New technologies, new techniques, we drive down costs, we find new oil, and we can keep these things producing. And that's what we believe we're able to do here in Thailand. So for us, it's an absolute pleasure to be here. It's a great pleasure to be up on this stage and to be part of the industry now in Thailand. And we continue to look for more opportunities here. So with that, I'll move on to my talk. Energy transition. So going to any conference in oil and gas over the past 5 years or so, even if it's an oil and gas conference, it's always energy transition is in every title. And to me, it was actually getting a little bit annoying, and yet here I am putting it in the title of my talk, as I have here. But what we're talking about is really the news flow that we're seeing about the oil and gas industry has changed dramatically. My belief has been, being in oil and gas, I've always been proud to work in oil and gas because we supply energy. And it's that energy that is used by people and countries to grow, to improve their standard of living, or to move even billions of people out of poverty. So it's something you could be proud of, the way energy drove that growth and that change in society. When you see the news now, we are much more the pariah. And I don't know how a lot of you feel, but when people ask me, oh, well, what do you do for a living? And it's like, you kind of mumble and say, I work in the energy industry, and kind of say, you know, hopefully they won't dig any more than that. Maybe one common feature that Thailand and Canada have in common is, right now it's more respectable to tell your family and friends that you grow and sell cannabis than it is to actually say that you work in the oil and gas industry. So another element is the news flow has been that our industry is in decline and that our industry is coming towards its end. And even a lot of the companies that are working globally, you see them responding in that way, which is, I'm not going to reinvest my money. If I have shareholders, I'm going to dividend those profits out. And what those companies are saying to people is, all we're going to do is produce these assets, give the money back to you. We don't see the investment there. And I don't agree with that. I think we have lots of potential here. And what I think is very important is that we kind of look through the facts that we have as to what energy is required, and that we as petroleum engineers see how we can extend our industry, but also how we can help in the transition change. And so before I really jump into the first slides, I do have to clarify a few things, seeing as this is going to be on YouTube, is I am not a climate change denier. I'm a geologist, and in fact, that's what we study, is climate change over the millions of years. But I do believe that human activity is actually causing the climate change, and we do have to address it. So I'll say that, and I might even repeat it a couple times, just so in case this gets out somewhere, because you guys are probably the easiest audience that I have to speak to on this topic. Okay, starting to look at some data. Surging investment in solar and wind. And this is going back about 10 years. And again, the numbers you're seeing here are quarterly investments into renewables, so solar, wind, and other renewables. And because it's quarterly, you can see if you've got 100 billion in investment there, then that's about 400 billion a year. So if we look at this year, the first half of this year, there's been almost 360 billion go into solar and wind. Now, if you make that for the full year, that's, let's say, 720 billion investment a year. That's more than last year the whole oil, gas, and coal industry invested in CapEx. So there is a massive amount of expenditure and money flowing into this. And I'm not saying that's wrong. I'm saying it's good. We do have to transition. And when people show you the plots, and this is going back for the past 30 years, you can see this massive increase in the amount of energy that's being generated from solar, energy that's being generated from wind. It's always in the news. You know, solar last year up 24%, wind up 17%. 60 countries now generating more than 10% of their energy from renewables, and that's very positive. But when we look at this on a full energy demand scale, it's a bit of a different story. Now, this is the world's total energy use per year back to the 1900s. But you can see from 1960 on, it's pretty well a linear increase of significant energy requirement and increase every year. Right? And that previous slide that I showed you with that exponential increase is that 7% that exists up in the top. Right? So while it looks very impressive, we still, with the amount of growth we have, it's still a very small proportion. And some of the key things to note, that the bottom, traditional biomass, essentially burning wood, we're still burning as much now as we were a century ago. Coal, we will burn more coal this year than the world has ever burned in a year. And you see our oil is back up as well. So I'm not saying that this is right, but I'm saying it's just the facts as to where we're kind of at now. That what we need is not just one source. We're going to need all of our energy sources to meet what the world needs going forward. And quickly, to show a couple examples, and this is not total energy, but this is just electricity generated in different countries. And to give you an idea, we hear a lot about electricity generation, but it comes for about 14% of the total demand for energy use. We've got the world up in the upper right. The interesting one we hear about is the United Kingdom, right? And you can see there, very well done. They've removed coal from the generation of electricity. Gas is quite strong, but in the past decade, they've really brought on a lot of wind and biomass, and that's almost, I think, almost half of their electricity is coming from renewables in that source. So very positive. Just Thailand for reference, it's pretty well gas and a continued growth in gas. However, the problem is the bottom left corner, which is China, which you can see there that coal is fulfilling all of their demand, a much larger increase there. And the other point to note is that the scale on these bars is that China is using probably 25 times more production. So the effect of what China is doing in coal is really swamping all of the other effects that we're having. Again, I'm not saying I agree with this, I'm just saying these are kind of the facts, and it's going to be hard to move away from this. And what's kind of disappointing to me as a Canadian is we had the opportunity to send tons of LNG into Asia a decade ago, and we made the decision not to because it was going to be more environmentally friendly to keep it in the ground. But all of that gas coming into Asia could have really helped offset a lot of that coal use. Okay. So that's really where we are at. Now let's look forward. Now this is from the U.S. Energy Information Administration. Great to see renewables as we move towards 2050 are going to increase substantially. However, the point to note is that liquid fuels, natural gas, and coal are also all going to increase as well. And when we looked at that great growth in wind and solar that we had last year, that did not keep up with the total energy increase that the world needed. So you needed these other sources still to come in and fill that gap. If we look at the European International Energy Agency, and they're always more optimistic towards the renewables, they show this decline in the requirement for fossil fuels as we get to 2050. However, when you look at it in detail, all of that decline is shown to be coming from coal. And it's really only saying that over 27 years from now, we'll only be using 1 million barrel a day less of oil and gas. The other key points on this are it says we will hit peak coal within the next few years. We will hit peak gas before 2030, and we will hit peak oil sometime in the 30s. I think those are probably optimistic, and just kind of the point on the right is to show the assumption in this is that the emerging and developing economies are still going to grow rapidly in gas, but don't worry, all the developed nations are just going to cut their production to keep that growth flat. So kind of the point we're trying to make here is that we still see oil and gas demand being required into the future. And just really trying to summarize that now and just really bring some of the facts to it. So if you look at, we're going to need a lot more oil and gas as we go forward. Natural oil declines, I think worldwide might be 7 to 8%. I'm sure one of you engineers will correct me on that if I'm wrong. So it says that annually we need to bring on about 8 million barrels a day of new oil production. New major projects are going to be required. Now, the interesting thing is when I went to university a couple of years ago, everyone was talking then about peak oil and that we were soon going to run out of oil. Peak oil will not be any more from what's in the ground. Peak oil will come from the demand side of the equation, that we have other sources that fulfill it. There's lots of sources of oil out there, lots of new basins still being discovered. But the other point to note is that the oil that we produce for the next 27 years is going to get more expensive and more effort's going to be required than the oil that we've produced for the past 27 years. It's just getting harder. So the last point I'll just show is just a slide from Reichstadt to try and bring it back to Southeast Asia. And this chart looks back 8 years at the projects that were sanctioned in Southeast Asia and looks forward 8 years at the expectations. And they're showing, while it's 44 billion looking back, they see 3 times that level of projects will be required as we move forward. That's a lot of effort, that's a lot of work, and it's a lot of capital. A slight caveat on that is probably that a lot of projects do get delayed, but it gives you an idea of the scale that we're looking at. So now what I see is a big challenge. Who's going to run this business? We're actually in a pretty good situation here in Thailand because I look out here, we've got 30, 40 students at the back who are coming into our industry. I do not expect if I was in Europe, if I was in North America, I would have the same. I would have more people who look like me, kind of at that point where you're saying, when are we going to retire here? Is it sometime in the next few years? And that's the thing that we're facing is we're going to lose a lot of the staff that we have because looking at requiring this out to 2050, that's 27 years from now. That's a full generation of people. That's almost full careers. How are we going to get the young people to come into our industry when all of the news about it is how negative it is, how damaging it is? Right, so this is what I see is going to be our challenge going forward, is really how do we staff the projects, how do we find the people? Okay, so that's looking at our oil and gas industry and still the demand there. Now, saving the planet, how are we going to do that? So in a recent UN report that came out, I think in the past week or so, it says to meet the Paris climate objectives of being carbon neutral in 2050, we need to scale up renewable energies. We've talked about that, it's happening. But we need to phase out all unabated fossil fuels by that time, by 2050. So we've just shown here, I believe we'll still be producing the same amount of oil and gas. That means we have to find a way to abate, get rid of all of the emissions associated with those if we're going to meet those objectives. So it's a tall ask. I won't go into too much detail on that, but we see that countries are moving in this direction, but they're all moving at different speeds. Most countries have set near-term goals by 2030, and normally it's reducing your emissions by 50%. We'll see how we do. And about a third of countries have committed to a net zero by 2050. Now, while that number is small, at least they account for about 75% of the emissions. And we also see when you look in the region that a lot of the operators here have set these net zero targets and are working towards it. So it's there, you know, the idea that we need to be doing this. The pressure is on, we need to transition. And how are we going to do it? It's just not by one technique, but replacement, I'm not going to talk about that. That's again, solar, wind, that type of need. Reduction comes in 2 areas. Reduction is first in consumers, obviously. The one thing I'll note here is I do find like our office seems to be air conditioned down to about 15 or 16 degrees Celsius. We could probably do better on that. But we also in our industry are going to have to find ways to actually reduce the emissions associated with our production. But importantly, and where I wanted to focus on this is really the last one. How do we preempt the release of the CO2 that's associated with it? Or if people are actually capturing it from the atmosphere, we still have that CO2, and we have to permanently get rid of it and store it in a safe way as we go forward. So removal of CO2 from the atmosphere, you've heard of biomethods, nature methods. A lot of people refer to these. Cooper Energy from Australia, they claim that they're actually carbon neutral now, went into Vietnam and planted more than 1 million trees. Major project, very positive, but there's been a move away from a lot of these nature methods. The other thing I'll comment on, if you look at pictures of tree planting on the web, it's always generally a parent and a child planting one tree. We're going to need more than that one tree. Tree planting's hard. I grew up in Canada in university. That was a job we had. You live in the mountains, you live in a tent for 3 months, and you walk up and down planting trees all day. You have to cover huge vast of lands with tree planting. But that was a bit of an aside. Direct air capture of CO2 from the atmosphere, that's ongoing. There are projects that actually work at this. But recognize that 400 parts per million, you need to process about 2,500 cubic meters of air to capture 1 cubic meter of CO2. It's high energy intensive and it's very costly. It currently doesn't make money. And then it brings us back to that problem. I have now successfully captured CO2. I have to have a way of getting rid of it, which is bringing us around to us. Putting it into the ground. This is really our industry. This is what we do. This example I put in just because there are 2 ways of storing this, and I'm a geologist, so I like to show subsurface pictures. So the first one, and what I can say seemed really natural to me, was when you produce a field, you've depleted the field, go and put CO2 in it. You know it's sealed, it's a depleted field, low pressure. But a lot of countries, Canada being one of them, doesn't allow you to do that. You're only allowed to inject it into saline aquifers. And essentially what you're doing is you're pumping it into a very permeable, porous water layer. CO2 gets absorbed into the water, and that's the storage mechanism that you have. So 2 methods, but again, the comment I'll make is this is not new for us. We've been injecting CO2 into reservoirs for years to enhance oil recovery. We know how to do this. So getting more specific on that, just trying to say this is really our industry, and this is where as petroleum engineers we can bring these skills. Gas processing, CO2 separation, that's what we do. Liquefaction of the CO2. Again, that's in our business. We do this. We're very trained in it. Transportation, whether it's by pipeline, truck, boat. Again, we understand this. We know the metallurgy that's associated with having to do this. This is our industry. And then you get to the subsurface, right? Where are the permeable layers? Injectivity. Top seal, seal strength, 3D structures, which then finally brings it around to our drillers, just drilling wells and injection, and how we monitor those. And the injection is not just during the monitoring phase, but also using geophysical methods in the future to track how we're keeping the CO2 stored safely. So the last thing that I haven't really noted here is the other aspect of these projects is these are major capital expenditure projects. And again, this is what we do in our industry is big major projects in the future. And this is being seen even now globally in carbon capture is with the projects that are ongoing. I think there's about somewhere 60 to 80% of them are delayed against plan, except the ones being run by the oil industry, which are only at about 19% delayed. And this is because it's our business. This is where we can really add value and where we'll need more staff to look after this. So just a bit of a summary on the current status, which is globally about 65 projects that are putting 40 million tons per annum into the ground. Now, I've tried to show it on the right here, which is the energy emissions, greenhouse gas emissions associated with our industry are about 37 gigatons. So when you look at the amount that's being captured currently, you can see it's about 1/1000th of that amount. Even with the plans to grow it substantially, it's still going to be a very small amount. It just comes to the renewable energy generation. We got a lot of work to do, and there's going to be trillions of dollars that kind of have to go into this field. and just really showing the plan of those projects as we move forward. Again, this is from, I think, Reichstad Energy, and showing a small of them really amount in Asia. Most of it is really coming in North America and in Europe. Okay, so now the key thing. How do we kind of make this happen? I hate to sound like a capitalist, but if you make it a business, if you make it valuable to put CO2 into the ground, the CO2 is going in the ground, right? But it has to become that business. But this is really where governments and everyone around the world is struggling now. How do we make this into a business and make it valuable? You can have a price on emissions, a carbon tax, right? So you're trying to create that negative incentive for people. There is a price on carbon now. You can do trading in carbon credits so that you can say, I put so much carbon in the ground, I'll buy the negative credits from this person there, so I'm actually getting value from it. Tax incentives are being offered by different governments in different areas, but this is really what we need, is that business model and the regulatory framework to drive this. And the problem is, it does almost have to come on a global scale, or you create a difference in competitiveness for our energy around the world. And just to try and put a few markers kind of on price. So if the average carbon price right now, like on the European trading of carbon, is about $100 per ton, US dollars, the emission from the energy sector of 37 gigatons, that's 3.7 trillion US dollars a year in costs associated with that. Now you stack this up against the capex in fossil fuels, about 600 billion. And the total revenue from fossil fuels, and you'll note I put question marks there because it's kind of hard to say what year you were in, but of about $8 trillion, right? So what's going to happen is people are going to have to recognize, I don't care how you do it or how you create that incentive, the consumer is going to pay. Whether it's through taxes or whether it's through carbon tax and that, the consumer is going to pay. And what we have to do is it has to come across as a realization. The problem is that's not really politically correct. No one wants to tell people that, but that's a fact. And just a couple of examples and to speak to a coordination in that. This is from Canada, what's the Pathways Alliance. And Canada generally produces now, I think, just under 5 million barrels a day. Over 3 million barrels a day of that is from the oil sands project. The 6 biggest producers in the oil sands got together and said, we're going to do this as a project, form the Pathways Alliance. Right, so they've gone together, and then they brought in the governments as well to cooperate with them, to get the tax incentives, to get the regulatory framework in place. And this is what you need, is this cooperation within industry and with the government to try and make this happen. So it's a good example of how you need to work together, but the main thing is set up the carbon capture in the oil sand, 400-kilometer long CO2 pipeline that anyone can access along the way, and then injection sites into saline aquifers in the region. But you can see the capex expectations of this just to get to 2030 are about $24 billion, which when you work it out of a capex per year is an increase in the capex in the oil sands of about 40% per year. Has to be accepted by everyone. But this is going ahead in this plan. And the only other thing I pulled from their website is just to show they have a plan to get to net zero in 2050, but capturing the carbon is not enough. You need to have all the other things. We need process improvements. We need electrification that's going to come from renewable sources. There is a lot of stuff and a lot of money that has to go in this direction to make it. And the last slide I'll put up is really just to bring it, because I'm speaking of Canada, but to bring it back to Thailand because you have a project here. Now, I'm not going to speak to this because there are many people in this room who can tell you a lot more about it, but I think the important point to note is from the PTTEP press release, and the points on the bottom is you need the CCS policy, regulations, and the investment promotion mechanisms to kind of make this happen. And that's what's going to drive it forward. So, bring it back to a summary. Oil and gas, I believe, is going to be around for a while. Renewables are going to grow, but I still believe that we will require oil and gas because we need all energy. we need to really be getting after the big projects, and therefore I see a future for all of us in this room, and especially for the students and the young people who are coming into our industry. And while net zero is going to be extremely challenging, it's really going after it and to try and deliver by both reduce, reuse, reduction, removal, all of the R's in that area. And the last thing I really want to say was just focus. CCS, carbon capture and storage, is our business. It's really our skill set and what we do well. And the final point, and this was just in one email I got from SPE this week. So next month, the gala in Houston, the title of it is Oil and Gas on the Right Side of History, Thinking Like Activists and Acting Like Engineers. And I thought that was just a nice way to leave it at that. So thank you very much.
Okay, now we would like to welcome your questions. Anyone have questions? พี่มนตรีค่ะ
Thank you, Sean. Thank you. That's a very nice talk, and you touch on key points that we are doing together in the industry. I've got 3 points that I'd like to touch on. But first of all, I appreciate what you're saying on the CCS. It's, you say, not someone else industry, it's us. If I can add, it's also the policy makers that have to make it happen on CCS. I do agree, and so happy to hear that we are now singing the same song. You know, we're talking about the same thing on CCS. We do believe, and your numbers, it's amazing. You're saying the whole world now doing 40 million tons a year. And you know what? If Thailand's going to go to net zero by 2065, as declared, we need to have CCS in that equation, 40 million tons by 2040.
Yeah.
And nothing moves today. He's showing Artit 2026 to start injecting, and I whisper it's now 2027. Because it's kept delaying, because no one make decision on that. We already make decision, the partner saying, well, what is the incentive, of course. But 2 more points I'd like to, thank you very much again that you touch on. First important point, you're saying you be very careful on touching on this point on Thai 1 and Thai 3. Thankfully, we do have a relatively sweet term to do the business here, in terms of producing fossil fuel, that's all we need. And I believe you are a newcomer, and you spend a little bit of time before you come. You study it carefully. You take all the obligations, not like what some of our friends who came 40 years ago, they not like to take the obligation. Being a global citizen, good global citizen, that we welcome you to Thailand. So that's the first one. The last point I'd like to make, thank you that you talk about energy preservation. We spend a lot of energy here wastefully. We waste all the energy. We produce, we sell energy. We like to sell more. But we would like to see you all preserve the energy. Not having all the AC up and then as you say, no need tides. So SPE, next time we come in, no tides. So we can have an open collar.
You're wearing a tie.
Because he's saying, coming to Thailand, you don't need tie, but when you come to SPE, look at him. So next time we agree, we have no ties. Okay? Thank you very much.
Okay.
Okay, my name is Haston, fourth year petroleum engineering from Chulalongkorn University. I have a question about the demand of energy that have been sharing and with agreement and also the advance of technology. I wonder how this parameter will affect our industry in about maybe 2050.
Yeah, just touching on, if I got the question right, it's really how can technology really help us, and how could technology help us reach these goals. Is that correct? Okay, I'll take it, yes.
Yeah.
Okay, and the first thing, obviously, what we would really all like to happen is a disruptive technology. That you get a new energy source, something that works very well, that can come on, that's carbon neutral and can replace us. And there's a lot of work going on that, but I would believe that even with the successful discovery of that new energy source, it is still decades to implement it. But when you look at our industry specifically, we are seeing a lot of things like AI and useful like that that'll really help us out on staffing as we can reduce numbers, whether it's seismic interpretation, the monitoring that's going on. A lot of this stuff, we can get a lot more value from AI that'll do that. But we are still going to need a lot of people on the rigs. But yeah, technology-wise, we'll always make it better and we'll help it improve. But there's the other aspect is we'd rather see it come in renewables and technology so that we get that cleaner source, right? Did that answer your question?
Yes, thank you for the answers.
Okay, Captain.
A great talk. I want to suggest a couple of things to add. One is the projected use of oil and gas going forward up to 2050, 2060 is probably the amount of oil and gas we've already consumed in the entire history of oil and gas. The other thing I want to add is you need to focus on people. We've got 8 billion. Sometime this year we hit 8 billion. The projection is up to 10 billion. And you just mentioned AI, and I'll digress a bit. What are those 10 billion people going to do if there's AI? Okay. People need to eat. What feeds people? Fertilizer. Where does fertilizer come from? Oil and gas and potash, but predominantly it comes from petroleum-based petrochemical ammonia urea products. From what I understand, the world cannot feed 8 billion people without petrochemicals and fertilizers. So you need to add that into your mix of when you present this again. And maybe it's also important to talk about the other pillars of civilization because people want stuff. I live in a village where everybody burns wood to cook their breakfast. And these people are poor as crap. Excuse me for that. But, you know, they don't even have motorbikes. They wait for the bus to come to take them into the market. They would like the stuff that I've got. I've got 2 cars, sad to say that they're both diesel, but people want stuff, and there's going to be 10 billion of us. And the only way they're going to have stuff is petrochemicals and steel and cement and plastics. All of this comes from our industry. And the renewables can't provide that in any way, shape, or form like we can. And somehow I think you need to meld that into your presentation, which was very good, by the way.
Yeah,
Yes,
thank
that
you.
wasn't a question.
Yeah, thank you for that comment, because one of the points the IEA, which is again the European group, when they did their oil outlook report at the end of last year, there's 2 key areas that they focused on that even when they see, you know, hopefully declining fossil fuels, oil is going to grow in 2 key areas, Asia, and the other one is petrochemicals. And it comes back to this manufacturing and how much oil is used in actually manufacturing of things, right? So thanks for the comment. Yeah.
Okay, maybe one last question.
Okay.
Hi, I'm Jean from Wadaxia, CEO of Wadaxia Global. I would like to pinpoint the question that you raised about human capital. And I think you noticed that growing into the business here, you said that you found that in Thailand there is a lot of human resource available because they are trained, but probably you noticed also that the industry in Thailand have been here around for about 40 years plus. We are now reaching to a generation that is leaving the industry. How do you feel, how big of a challenge you think human capital will be for you here in Thailand in the coming years? Because you noticed that, I heard you saying that, so I think all of us, we noticed that picking engineers out of university into specialties that we need in oil and gas industry here, especially upstream, is becoming more and more scarce. So what is your take on that?
Yeah, and you know what I think was really great, and it's good to be at this SPE event. And what you saw was so much of the focus at the beginning was on the interaction with schools, the interaction with youth, and trying to bring people into our fold and our technology. I think that's very positive. And again, to me, to see all of the young people here, to see the young presentation is very good. So when I'm in Thailand, I feel very positive about this. When I go back to somewhere like Canada or into England, I'm much more pessimistic. You're seeing a 40% drop in students in geology. You're seeing programs being closed, both business as well as petroleum engineering type courses. So I'm much more negative about what's going on here. And that's why, again, why I like Asia and why I want to be here is because there's still a respect for that energy and the importance of the energy. And we're actually attracting these people still into the business rather than having to hide our heads and say, no, I'm, pretend that we're just doing energy. So thanks. That was a really good comment. So thank you very much for this. And where's my fish?
Okay. Can you please, Dr. Sean? So we would like to ask our chairman, Khun Ronald, on stage to present Dr. Sean Guest with our token of appreciation. Okay, I would like to remind all the guests, if you haven't write your name on the lucky draw docket on your table, this is your last chance, as the hotel staff will be collecting them now. Does anyone have not yet provided your name? Okay, now I have a few closing remarks. Next year in August, the Asia Pacific Drilling and Technology Conference and Exhibition will be back in Bangkok. So if you have something to share, please consider presenting a paper there. And also in 2 weeks' time, on September 28, the SPWLA will have its monthly meeting at the Jasmine Hotel. Khun Nattapon from Chevron will present something on low salinity water flooding. If you have time, please support them, and the entrance is free. And we will be back here at the Landmark Hotel on October 19 for the SPE monthly technical program, which occurred every third Thursday of the month, with Dr. Chris Atkinson from Helios, Aragon, with a presentation on natural hydrogen exploration. We all hope to see many of you there. and sharing the event for your benefits. The International SOS Foundation is organizing Asia Health, Wellness, and Security Conference 2023 here in Bangkok next month. You can scan and find out more detail as well as register via the QR code shown here. The entrance is also free. And then finally, the lucky draw. The Landmark Hotel has provided us two lucky draw prizes. The first one, we have a voucher for a buffet lunch at the Chinese restaurant here at the Landmark. And the second prize is a voucher for a weekend brunch at the Ribs Room on the 31st floor for 2 persons. So thank you to the Landmark for sponsoring this lucky draw. So may I please ask first our young professional winner to draw out the first prize of the lucky draw. Khun J. Anguiano from Reset Energy. Yay, he's here. Thank you. And may I ask Dr. Sean Guest to draw the second prize? Khun Malai Tip from Prince of Songkhla University. Okay, Ka. Okay, and a special thanks to Valeura Energy who support the organizing of this evening so we can all have a nice 3-course sit-down award dinner. Okay, we still have dessert coming out, so please remain seated for the dessert. And this is my last slide. So after the dessert, if you would like to have a few more drinks, we have at the Rendezvous bar downstairs a 2-for-1 special, but you need to give them a code, which is SPE, so they can give you the 2-for-1 drinks downstairs at the Rendezvous bar. And one last round of applause for our sponsors. And have a good night. Thank you, Ka.
There's no comfort in the truth. all. I feel so unsure as I take your hand.